What's going on, guys? It's Cameron from Tinker's Musings here. I do apologize, first of all, for the lack of content the last month or so. It's just been a bit hectic, and I'm looking forward to getting back into content creation on a more regular basis. Today we're going to be covering upgrades in my home lab. Let's get started. Alright, so one of the biggest upgrades of the home lab that I've been working on is the transition from 120 volts to 240 volts. And essentially, the reasoning behind that is when you get to a certain capacity in your home lab, you have so many watts being drawn from a socket at a given time. And currently, my garage setup has 15 amps available on the basic circuit for 120 volts. And this is fine, generally speaking, but I'm hitting a point where I'm going to be surpassing what is safe for a single socket, and I'm looking at long-term build-out and future expansion. Currently just in a half rack, but when planning out your home lab, think about what you want to achieve. Maybe you don't need as much power as I do. I'm probably not going to use all the available power, but it gives me the flexibility to spin things up and down with ease of mind and not worry about overloading my circuits. So, as part of the plan, I'm getting a 30 amp 240 volt circuit installed. The previous owners of this house had a spa or a hot tub circuit that was 250 volts, 240 volts. And it's a double pole breaker, 50 amps. That available capacity on the breaker panel is what I'll be repurposing for the 30 amp circuit that will be installed in the garage. And as you can probably see here, we have this 5000 volt amp 208 volt rack mount 3U UPS, and it's actually a pretty decent unit. It has capacity for I think 3500 watts, and that means 3500 watts at 208 volts. I am bringing in power at 240 volts, but the UPS delivers at 208 volts. It will take anything from the high 100s to 240, and maybe a little higher as input voltage, and then output 208 volts. And so when you take, say, my current setup, which is about 1000 watts or a kilowatt, and you divide that by 208, that gives you the amps that it draws from the wall. So in order to calculate amperage, we would take 1000 divided by 208, and we get roughly 4.8 amps. When I was planning on this, I wanted to make sure I got a unit that could handle a significant load. I went back and forth with people in the community about whether 20 amps or 30 amps would be best, and 30 amps ultimately is where we settled, where I settled actually, and it was very strongly recommended that this is the direction I would go. So this unit has been discontinued recently. Actually, it was discontinued as of December of 2021, and it's now out of service technically. I bought this unit used on eBay. It came with 2 new batteries, and the batteries, they slide in on this side of the UPS. You take the front bezel off, and then you slide them in, connect the front panel connectors. They shipped separately actually, so the unit came in one box, and then the 2 batteries came in the other box. These rails were also part of the package, so that's really nice. I have mine mounted on the bottom of the rack because it's heavy, And you always want to put your heavy things on the bottom of the rack so your rack isn't top heavy. So keep that in mind when you're building out your home lab and the center of gravity. Now, this is a 30 amp socket that is needed. It requires a NEMA L630R. That's the receptacle. If you can see here, I actually have this receptacle that I just purchased. I'm also looking at getting this little DROK thing wired up alongside it so you can see the circuit, power draw, the amperage at a glance. This is going to be neat if you're like right there in front of it, but I'll get into more of what you can do from a networking perspective in a little bit. However, this is your L630R, and this is a 3D printed bracket. Actually, it will fit on a standard junction box that you can get. I attempted to print a junction box that had some mounting points, but it didn't turn out quite right. I need to tune my 3D printer to clean that up, but I think I'm just going to use this custom plate on top of a box that I buy at the hardware store. So, in terms of what you can do with this, this is a double conversion UPS, which means it takes the AC power, 240 volts, and it will convert it to DC power. And then from there, it converts DC back to AC. So by the time it gets to your equipment in the rack, you've actually done 2 conversions. And this is helpful because if you have a disruption in the main power, it protects your devices from any surges or potentially electrical storms like a lightning strike nearby. I have not deployed this yet, so I can't speak to experience whether it will keep things from turning off, but this is a pretty high-end UPS, so I'm hoping that it keeps everything protected in the rack. The included cable is 10 feet, so that's plenty. It gives you lots of room for different placement of the socket on the wall, and you can have your rack not necessarily right next to the wall, so you have a little breathing room. In terms of what you're able to do, the UPS itself has management capabilities, and mine actually came with an older version of this management card. So I bought this new management card by recommendation of the community, and this gives various ways of interfacing. So you have USB, universal I/O. I think those are for sensors. You can get sensors for like humidity and possibly temperature. And then this will connect into your network. It's 10-100. There are newer versions of this card as recommended. You can get version 3 of this, and I believe the version 3 even supports gigabit if you need it. But these aren't really high demand. This isn't really that high demand, so I can't imagine more than 100 megabits being needed for this. So if you buy a unit that is from APC, aka Schneider Electric, then you can see if it comes with a card, and if it doesn't come with this one, then you can decide whether you're going to replace it or leave the one that it ships with. The reason I bought this card is because it comes with the newer firmware and a newer interface. And as I get this set up over the next week or so, I'm going to be looking at what you can do with this over the network, and we'll cover some more videos on the management of this. I've actually looked for lots of documentation in terms of videos about what this card can do, and there's just not very much out there. So I'm hoping to provide that as a resource for you guys if you are interested in purchasing a card such as this. Sockets for the output state that you have 2 of these L620Rs and 2 of the L630Rs. Does this mean that you can support more than the rated amperage? No. It just means that it accepts those plugs. You still have to stay underneath the 30 amps. None of your equipment has any way of natively connecting to these sockets. So this is where you need to get a power distribution unit. This APC PDU is a 0U 2G metered PDU. And what 0U means is that it doesn't actually take up any horizontal space. This provides power to your equipment. This is actually a half rack size, but they also make it in full rack. So if you've got a full rack, then it would be about twice as many of these sockets. So on the input, we have a C20 socket. That is a 20 amp plug, and it will go to the L620P. So with my setup, I have decided to go with this because it's a half rack height. I've actually not been able to mount it inside the rack currently because I don't have a full length rack. It seems to be just a bit short, so they don't have the inside mounting area for this sort of PDU. In order to connect equipment into these, you need a C13 to C14 plug. Probably on the variation like 2 to 3 feet, because we're not going to be going long distances with these cords. And they can be rated for, 10 to 20 amps each. It's okay. None of your servers are going to draw that much on their own. So that's what we do. There's also a couple of these C19, and I'm not entirely sure of the application for those because I don't have anything that uses these. But I think you could maybe daisy chain or go to a higher amperage device with this socket if you needed more power. On this PDU, we have a screen, and on the screen we actually get to see readout for current load as well as some other information. There's some sensor input here and a USB input. So I don't know all of what can be done there, but probably temperature and humidity is. But what we'll be most interested in is the network interface, the ability to monitor the load from the network. And I'm going to cover that as part of the APC monitoring video that will be coming out soon. So this is rated for 20 amps, more than enough for what I'm going to be doing. It has 18 of these C13 plugs, as well as 2 of the C19. If you're running 208, make sure that your devices can do dual voltage. If you have to make a switch, a manual switch, do that before you try to run it on 208 volts. You'll run into problems. You might actually even fry some components if you attempt to run on 208 volts when it's configured for 120. So just be very careful. I think a lot of modern power supplies, especially server power supplies, will do dual voltage without the need for manual switching. I'm actually going to be getting power installed this weekend, and then I'll be able to get this all online, and I'll be able to start putting together content on remote management for the APC gear. Really excited to get that going. I'm looking forward to being off 120 volts and having more safety Well, that'll wrap it up for this video, guys. I hope you enjoy. And if you have any questions about how you want to plan out your power, or if you want to tell me about what you've been doing in your home lab, feel free to leave some comments down below. And please like and subscribe and hit that bell notification icon so you can be notified of the next video. Alright, I hope you enjoyed. We'll talk soon.